All right. Are we good? All right. So we're on section 1.2, solving equations using a graphing utility and linear and rational equations. So our objectives for this section are solve equations using the graphing utilities, aka a calculator, solve linear equations, solve rational equations, and solve problems that can be modeled by linear equations. Okay, what is an equation? Well, equations, an equation in one variable is a statement in which two expressions, at least one containing the variable, are equal. Pretty straightforward. So a simple equation is 2x equals 6, right? So the expressions are called the sides of the equation. So we have a left side and a right side. So when you have an equation, the goal is for it to be true or false, depending on the value of the variable. And so these are what we call our solutions or roots of the equation. So we are going to refer to them as solutions or roots. To solve an equation means to find all the solutions, like all the possible things that would make it a true situation. So just basically writing the solution out is called a solution set. So there's more than one solution. We write it as a set. Sorry. And when you're writing as a set, it typically is writing it with braces. So an example, I would have 1 and 2. That I make the worst braces, by the way. All right. So any equation that is satisfied for every value of the variable for which both sides are defined is called an identity. So what this is saying is if it comes down to x equals x or 2 equals 2, then that means you have what's called an identity. And therefore you have infinite solutions. Okay, so here are our types of solutions to equations. The first type that we have is conditional. And conditional means that you have one unique solution. So the final line is going to be x equals a number, or the variable equals a number. Okay. Then you have what's called contradiction equations. And that means that there is no solution. And that's because it comes down to having a false statement, an invalid statement, such as 0 equals 1. Is that true? No, that's false. So therefore, it's a contradiction equation. And for the most part, we would just write no solution. And then the last type of equation is an identity equation. It means it has infinite solution set. And the final line is a true statement. A number is equal to itself, or a variable is equal to itself. But your final line is a true statement. All right, so contradiction, identity, or conditional equations, meaning we have one solution, no solution, or infinite solution. Questions so far about the types of solutions? Okay. So we're going to talk about solving equations using a graphing utility. For your unit 1 test, you have a calculator portion of the test and a non-calculator portion of the test. So we go over how to do things algebraically and we go over how to do things graphically, okay? So make sure you're comfortable with both because your test is split between calculator and non-calculator, okay? So we're going to go over how to solve an equation using a graphing utility. Did anyone bring the batteries? Oh. And find your intercepts. Okay. Way number 2 that we're going to do is when you graph. So you're going to graph and find intersection. Okay. The first way is good if it's equal to 0. So if it's already equal to 0, then you do here. If it's equal to anything else, then we find the intersection. So this one is x cubed minus x equals 1 plus 1 equals 0, right? So that means we can just look for our x-intercepts. I meant to put x, my bad. Our x-intercepts. So I'm going to grab my calculator. I'm going to turn it on. When you're clearing your calculator, if you don't want to have to like go in and delete, you press second plus 712, and it just automatically resets it. So I'm going to go to y equals second plus 712. So I'm going to put in x to the third minus x plus 1. I'm going to go to the graph. And I need to be able to see where it intersects the x-axis. So I can clearly see where it does. If I want to, I can zoom in a little bit more. But is it necessary if I can see the point of intersection? No, it's really not. But if you want to, you can choose to zoom in. Like, yeah, let me zoom in a little bit more around that center. To zoom in, you just move the cursor, hit enter, and it'll zoom in a little bit more. To find my x-intercept, remember that's also called a 0. So you press second trace, and you're going to go to the 0. Then you press enter. And you want to start just like you read a book. We start from left to right. So I'm going to take my spider, go to the left, hit enter. And then it tells me to go to the right, hit enter. And it's like, are you sure you want me to guess? Yes, Mr. Spider, I do. And it tells me that my x equals -1 and roughly 3200. Okay. How do you feel about using it to find the 0? Cool? Okay. Now, the second way for a graph and find the intersection is if it's not equal to 0. You're going to put in both parts of it. So notice on this one, we have 4x to the 4th minus 2 equals 2x plus 2, right? Am I equal to 0 anymore? No. So method number 1 isn't going to work. So we're going to have to do method number 2. Method number 2 is you're going to put in the left side of your equation in y1, and then you're going to put the right side of your equation in y2. So I have 4x to the 4th power minus 2 is my left. Then I have 2x plus 2 on my right side of my equation. Questions about inputting in for y1 and y2? Okay, then we hit graph. When you graph, you want to make sure you see all points of intersecting. And notice here, I do not see if it intersects further above. So I'm going to zoom out or zoom fit, whichever one you want. I'm going to do zoom out because I feel comfortable moving it and saying, no, I need you to go up a little bit. And this just tells it what direction you want it to zoom out to. And I needed it to zoom up. So now I see both points of intersection. That means that there are 2 solutions to this problem because there's 2 points of intersection. Notice how we're saying the word intersection. So that means when I go to second trace, I'm looking for the intersect. So I hit enter. It's going to ask you, where do you want me to guess? So you're going to have to do this twice. So the first time you do it, you want to make sure you start from the left of your graph. So here's my first curve, second curve, and then guess. Yes, I want you to guess. So my first solution is roughly right here. And you're looking at the x value. So my x equals negative so I have this point of intersection. It's at negative 87 hundredths and 27 hundredths. So x equals approximately negative 8,700. That's one, but there's another point of intersection. So I got to find that other point of intersection. So I'm going to go second trace, go back to intersect. And this time I'm going to move to the right of my graph. So I'm going to move to the right. And now I'm like, yes, yes, yes. And it says my second point of intersection is at 1 and 12 hundredths and 4 and 23 hundredths. So my other x value is x equals 1 and 12 hundredths. And it told me to round to the nearest 2 decimal places, which is why I did that. The calculator will also automatically round for you if you have that mode on. So if you have the mode for it to round to the nearest instead of on float.
And I also.
All right, so when you do this, when you change the float, now when you're finding your intersections, it'll automatically round for you. So notice how now it'll automatically round to 2 decimal places. So if it already has a set value for you, you can have the calculator find that for you. Okay. All right. How do we feel about using the graphing to find 0 and intersect? Easy enough? Okay. Do we see the difference of when to use them? Literally, you use the 0 when it's equal to 0, and you use intersect when it's not equal to 0. All right. So this just summarizes the steps for it if you need them. They are written out for you on in your notes on Brightspace. So it summarizes it for you to reference and come back to. Yeah. Cool. All right. Now, solving linear equations by hand, algebraically. Rules for solving linear equations. The goal is to isolate the variable, undo operations with their opposite operation, and always do the same thing to both sides of the equation, right? Simple enough? We got that. So for example, here, interchange the 2 sides of the equation. If I have 3 equals x, I can simply switch it to x equals 3 and be done, okay? Simplify the sides of the equation. So before I start moving things across the equal sign, I want to make sure that both sides are completely simplified, okay? And then add or subtract same expressions. So I want to combine like terms if possible. Not combine like terms. I want to use inverse operations. So I want to add or subtract first before I start multiplying, dividing, and powers and stuff. Okay, then I'm going to multiply and or divide. And then lastly, if there is a power involved, then I will utilize the power and or parentheses. Okay, so basically what we're doing is, we all know PEMDAS, right? This is when you are evaluating. When you are solving, you're going backwards. You're doing what I like to call SADMEP. Okay, so you're gonna first, is there anything I can add or subtract away? Is there anything I can multiply or divide away? Is there any exponents? Are there any powers? Okay, so we're gonna go backwards. So tomorrow, we will actually go through and solve the linear equations algebraically, and that will be it. And look at a couple word problems.